Hello and welcome to my e-poster. My name is Kirsten Stevens and I am a PhD student at Penn State University working with Dr. Christelle Wauthier. And today I'd like to talk to you about some of the research I've been doing at Masaya caldera located in Nicaragua using INSAR datasets to look at ground deformation within the region. What I've shown in the background here is a picture of the lava lake that formed at the summit of Masaya in December 2015 and is currently persisting to this day. So in this classic cross-section of the Kilauea magma plumbing system on the Big Island of Hawaii, we see a number of different rift zones, magma plumbing reservoirs located at the summit, and some kind of transient ones throughout the rift zone. And so when we see this, it kind of raises questions of where is the magma being stored, for how long is it being stored there, and how and when and where is magma being transported. And particularly in the geodetic community, understanding what types of ground deformation patterns are characteristic of different types of volcanic activity is really important for forecasting and mitigation of future volcanic risks. So as I mentioned, my focus has been at Masaya caldera, located in central Nicaragua and about 20 kilometers to the southeast of the capital, Managua City. And so within the caldera itself, there's a number of nested pit craters, and in particular, the Santiago pit crater is currently hosting the lava lake that formed in 2015. So I'm showing over here a cross-section that's going from just south of the summit up through the north. And this is basically the magma plumbing system as has been imaged by previous INSAR studies. So up at the summit, a period of explosive activity in 2012 was imaged with sub-centimeter displacements, suggesting there were changes in the conduit just below the summit and linking to a reservoir at about 1 kilometer's depth. And over here, a more recent study found an inflating reservoir located to the north of the summit associated with a period of lava lake activity. A number of studies have postulated that we had fresh magma coming in from depth into the system at this particular reservoir and then traveling from there to the summit. So I want to understand a little bit more about how this changes in magma influx and outflux to this reservoir are linked with periods of volcanic activity that are observed at Masaya. And so in order to do that, I obtained a number of different radar satellite data sets, namely Sentinel-1, and then through the CEOS volcano demonstrator, Cosmos SkyMed, and RadarSat-2 data sets. So what you'll notice is a combination of descending and ascending data sets, which means I can decompose my line of sight measurements of the ground deformation into vertical and east-west components. What I've shown here in the background is different periods of volcanic activity at Masaya, explosive periods, periods of incandescence, so non-permanent lava lake activity, different periods of kind of small explosive eruptions, and then the period of the persistent lava lake. And so plotting up the ground deformation centered over the Masaya Central Reservoir, we're showing over here the white circles indicating vertical displacements and the black circles indicating the east-west horizontal components. Again, with the different volcanic activity shown in the background of this. What I've also plotted here is the carbon dioxide sulfur dioxide ratios obtained from Alessandro Ayupa and others. And this is shown in the blue squares. So what we notice is that over time, we have these different periods from P1 to P5 where we have kind of changes in the gradient or the rate of displacement over this particular central reservoir. And in particular, at the around the peak of this carbon dioxide sulfur dioxide ratio, we see this increase in the rate of displacement of the Masaya Central Reservoir. And this is indicating we've got this influx of fresh magma coming into this region and then traveling to the summit. We've got a period of kind of inflated but not changing ground displacements, followed by a period of very gradual and slower kind of depressurization of the system. So I'll be doing volume change modeling over these different periods and linking that with the volcanic activity at Masaya, as well as linking that with different periods of kind of regional and local seismicity. So thanks very much for coming to my e-poster. I'll just leave this summary slide up here, and I look forward to having any discussions with anyone who is interested in this work. Thanks so much.